Hi, it's Dr. Nick with the ECG Academy, and this advanced Chalk Talk starts out pretty simple, so it's a great lesson for beginners as well as very advanced readers. So looking at this rhythm strip and looking at the forest, we can see there are two populations of QRS complexes. There are narrow QRSs that look like they have a P wave in front of them. They're a little bit faster than 50 beats per minute, probably about 52 or so. And then there are these wide complex beats that seem to be sandwiched in between these narrow beats. So you have what looks like a sinus bradycardia that's kind of marching along, and then you have these two wide complex beats kind of sitting there. So you have to figure out, are these PACs with aberrancy or are they PVCs? Well, most people will look at them and figure it's a PVC. And the reason is, number one, it's kind of wide and bizarre and it doesn't really look like the normal underlying beat. And the second reason is if you look in front of it, this T wave looks exactly the same as the normal T wave, so there does not appear to be a P wave preceding this beat, because if it was a PAC with aberrancy, you should expect to see the P wave that gave rise to that QRS complex, and we don't see it. So for you beginners working on telemetry units, we would call them interpolated PVCs because they're in the middle of two normal beats, like sandwiched together. You could find this on other EKG blog sites, and they show you how the QRS complexes are marching on through pretty much at a very stable rate, and the reason is that the PVCs don't interfere with the sinus rhythm. And the idea is that the sinus node is firing at a steady rate and giving rise to these P waves, but these PVCs are arising, and they're timed at such a point that they're not able to retrogradely penetrate the AV node, and so they don't affect the sinus rhythm, and that's why the next sinus beat occurs on time. But you know, that explanation bothered me a little bit, because when you look in front of this QRS complex, I don't see a P wave here. So where'd that QRS come from? Well, supposedly the P occurred on time, but the PR interval got longer because of retrograde penetration or concealed conduction of the PVC into the AV node that caused the AV node to conduct more slowly. Well, if you take your calipers and very carefully measure the onset of the P wave and you come to this next beat, you would expect to see a P wave there. If the P occurred on time, but conducted with a first-degree AV block because the PVC penetrated the AV node and caused the AV node to slow down, that next QRS complex should occur later, but it didn't. So where is the P wave? The P wave clearly must have occurred much earlier than it should have. And then if you move the calipers over, you see that the next P wave is a little early. Now you might say, well, that's just sinus arrhythmia, but let me show you how the same thing keeps happening. Here's this P to P, and we come over and we see that the P wave should have occurred here, but it's not there. And the next P wave again occurs a little bit early, although the sinus rhythm is really quite regular. So this is a bit more complicated than it appears. So for basic readers, interpolated PVCs would be the correct answer. But electrophysiologists have to explain why the P wave does not occur on time here, and if that's the case, where did this QRS come from? What you have to remember is that there are extensions of the AV node into the atrial myocardium. The one that extends into the atrial septum is known as the fast pathway, but there are other extensions along the tricuspid annulus, and in most patients extending onto the left side, and these conduct much more slowly, so they're considered slow AV nodal pathways. So let me show you what seems to be happening here, step by step. Start with these first sinus P waves. This is the interval from one to the next. If you measure across, that's where the P wave should land, but it's not there. So what seems to be happening is this PVC down here in the ventricle is actually able to get up the His-Purkinje system, up the AV node, and the fast pathway conducts that P wave back to the atrium. But we can't see it because it's somewhere buried in the QRS or the T wave. But that retrograde P is able to penetrate the sinus node and then reset the sinus node. But in the meantime, that P wave turns around and enters the slow pathway where it's delayed. So then in here somewhere is a retrograde P wave that then conducts with a very long first-degree AV block and gives rise to this QRS complex. But because the PR interval is so long, we don't see that P wave. But the P wave then has to get into the sinus node, reset it, and then that impulse has to come out of the sinus node to give rise to the next P wave. And if you move your calipers to the next P wave, you can imagine that somewhere in here is where that P wave occurred, because by the time it gets into the sinus node, resets the sinus node, and then it takes this long for the next sinus P wave to occur. But that explains why this P wave is not on time. It comes a little bit early, because it's the retrograde P wave that establishes when the next sinus beat's going to occur. So this very complicated explanation is the reason why interpolated PVCs are often followed by what look like junctional beats, even though there should be a P wave there. Well, this explanation will definitely raise a few eyebrows. Until next week, this is Dr. Nick with the ECG Academy. Thanks for watching.